Hi guys. So today we're going to look at how to solve a polynomial equation. Now again, this is something that you did see in Algebra 2, but it was kind of a hard process back in Algebra 2, so it's one we definitely need to review. So whenever we solve a polynomial equation, what we're either going to do is we're either going to set it equal to 0 and solve it, like we did with quadratics, or we're going to take the function and find the zeros. The process is going to be the same, but that's just two different wordings that you'll see in the directions. Now, one thing to keep in mind that's going to be helpful for us to know is that the degree of that polynomial is the same as the total number of zeros. So, for example, if I have a polynomial that's a third degree, that graph is going to have 3 zeros. If it's a fourth degree, it's going to have 4 zeros. Now, those zeros, they could be imaginary, they could be squared, they could be irrational, which we'll talk about that in a second. But no matter what they are, there's going to be the same number as there is the degree. So what I mean by that to start, let's look at this first one. So to solve this first one, we are going to factor it using the sum and difference of cubes formula that we learned back in Algebra 2. So sum and difference of cubes, so we have the formulas over here. But one thing that you guys may remember is an acronym that you learned to help you remember how to get this little trinomial. And that acronym is SCUMS. Now the U didn't mean anything. The U just helped us remember the word. But what that acronym stood for is how we get this trinomial. And it's written down there, but let's go ahead and do an example. So the way I factor this, I know the cube root of this and the cube root of this. So my first thing is the 2 cube roots. So that's x minus 2. So then I'm going to get the trinomial, the 3 terms. And this is where I follow the SCUMS acronym. So the first thing I do is I square the first. So I'm going to start by squaring the x. The C stands for change the sign. So that was minus, so I'll change it to plus. The M is multiply, so 2 times x. And then square the last. So I'm going to square that too. And that is how I would factor this. All right, so now I'm going to use, it says to use the quadratic formula to find the imaginary zeros. So if I want to find all the zeros of this polynomial, it's a third degree, so there's going to be 3 zeros. Well, one of these zeros is really easy to find. It's going to be x equals 2. The other zeros, though, are going to come from that quadratic that's in that factor. So I can do the same method I did whenever I solved quadratics. I can take that factor, and I can set it equal to 0. But this time, I can't really just solve it as easy as adding a single number. I'm going to have to use the quadratic formula to actually be able to solve this. So remember, quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's fill in our values. So 2 squared minus 4ac all over 2a. So then from here, we can simplify. So that's going to be 4 minus 16, which is going to be the square root of negative 12. And I'm going to go ahead and move this up a little bit so I can get some more space here. All right, so the square root of 12, I can take 12 and break it down. All right, so I end up with a pair of 2's. So 2 can go on the outside. Because it was a negative on the inside, I'm going to make it I. And now there's a 2 at the top in both of those spots. So all of my 2's can get divided. And I'm left with negative 1 plus or minus I root 3. So what you'll notice here, this was a third degree polynomial. I have 3 answers. I have x equals 2. I have x equals negative 1 plus I root 3. And I have x equals negative 1 minus I root 3. So those are my 3 zeros for that polynomial. All right, let's try another one by factoring first. This is one we can factor by grouping. So the normal method we use when a is greater than 1, this is actually just like the second step. So these are actually pretty easy because it kind of gives you the first step. So out of those first 2 terms, let's take our GCF. Then let's go to the next 2 terms. Our parentheses match. And everything that's not in parentheses is left. And then we do the same process. Okay, now remember, this was third degree, so I should have 3 zeros. So I get x equals 2 for one of them. And again, this one's a little harder to solve. I don't have to use quadratic formula. If I subtract 4 from both sides, now I can square root both sides. And remember, whenever you take a square root, it's actually plus or minus. So that's where we get our two answers from. The square root of -4 is 2i. So I get 3 answers. Third degree, 3 answers. X equals 2, x equals 2i, and x equals -2i. Now, one thing you may start to notice happening, these i's are coming in pairs. You have plus or minus for both of them, and that's going to be true for square roots as well. All right, so this next step you may have seen last year. This is how we find the possible rational zeros of a polynomial. Now, I will tell you right now, we are going to go a different way than using this method in the class this year. But this is helpful for you guys to know because you may need this for solving polynomials later on if you don't have a calculator available. So if you don't have a calculator available, this is the method you kind of have to use. But for now, if this bothers you, don't worry. You don't need to worry about this part. I'm just kind of showing it for you guys if you need it in the future. Okay, so this is the possible rational zeros. So not necessarily numbers that actually are zeros of this function, but all of the rational numbers that could be. So to understand what I'm talking about by rational, rational numbers are the nice kind of pretty numbers. We can write them as a fraction. They could be positive, they could be negative, but they're possible to be written as a fraction. Numbers that are not rational are called irrational. And those are a lot of those numbers that you get from quadratic formula. The square root of 5, 2 plus the square root of 3. Those are examples of irrational numbers. If you were to find them on a graph, they'd be really ugly decimals that you can't find a nice fraction for. Now, the other options are imaginary numbers. Those are the ones we just saw. And those are whenever you have the I or the square root of a negative. Okay, so this process helps us find the possible rational zeros. So I'm gonna go through this. Don't stress too much about this part. This is, again, just more for later on in life if you end up needing it. So P is all the factors of the last number, the number without any x's. So all the factors are 8 are going to be plus or minus 1, 2, 4, and 8. Q is all the factors of the first number. So plus or minus 1, 2, and 4. So then what we do is we do every possible combination of P divided by Q. So I would take each P and divide it by each Q. So I've got 1, 1/2, 1/4. Then I'll take 2 and divide it by each Q. So I've got 2. 2 divided by 2 is 1, which is already on my list. And 2 divided by 4 is 1/2, which is already on my list. Okay, take 4 and divide it by each. The other ones are already there. And then take 8 and divide it by each. And those are all the possible rational zeros. All right, let's look at this last one. P, the factors of 5. Q is the factors of 6. And then we do every possibility of P divided by Q. And then I'll do the 5 divided by each one as well. So I get 5 over 2. So those are all the possible, again, rational fractions. They can always be plus or minus. Again, we're not going to really use that as much today because what you guys would have to do without a calculator is actually take those points and guess and check using synthetic division in order to figure out which ones actually work. Now, that process takes a long time. It's super tedious, and it can be a little frustrating. So what we're going to do instead for you guys is we're going to let you guys use a calculator to be able to find those values. But we're still going to do the same process, all right? So this first one, okay, it tells us 1 is a 0, all right? What we want to do is we want to factor this polynomial. Now, this polynomial right here, we can't factor it using any of our normal methods that we normally use because this is cubed, not squared. So what we can do is go through this synthetic division process. Now it tells us that 1 is a 0. Okay, so that's the first thing we know. If 1 is a 0, as we've talked about, x minus 1 is going to be one of our factors. The problem is we don't know the other factors. So what we're going to do then is we're going to use synthetic division to find a quadratic out of this. So if 1 is a 0, I'm going to do synthetic division with 1 in the box. And this is very similar to what we did last class. So I'm going to use 1. I'm going to remember to put my 0 because there's no x squared term. Write my coefficients. Bring down my first. Take the number at the bottom, multiply by what's in the box, add down the column. Multiply, add, and I get 0 as a remainder, which I should, because I'm proving that 1 is a 0. By getting 0 as a remainder, that shows it. That also proves that x minus 1 is a factor. All right, now remember, when we do synthetic division, we're going to start 1 degree less than the original. The original was x cubed, so my answer would then be squared. Well, now we want to factor this completely. So now I can factor what's left over. Well, what's left over, that's really easy to factor. Okay, a is 1. We're looking for what multiplies to negative 6 and adds to 1. Well, that's going to be 3 and negative 2. So because that's the factors we got from the quadratic, we also have that x minus 1 that we had from the beginning. Now I have what actually this original question factors into. All right, well, let's keep going. So we're going to use the same concept, except instead of factoring this time, we're going to actually solve and find the zeros. Okay, so again, like I told you guys, if you don't have a calculator, you would have to do that P over Q process and guess and check with synthetic division until you get 0 as a remainder. That process can take a really long time. So what we're going to do instead is we're going to take a graphing calculator, and we're going to use that calculator to find any real rational zeros that we can find. So I can't graph on this video. I'll have to graph a separate video for you guys to see how to do this. But again, the zeros are the values when f of x equals 0. They're the x-intercepts. So I'll show you in a separate video how to find those, but we'll go ahead and tell you if you were to graph this. So you would end up with x equals 4 is a 0 for this graph if you were to actually graph it. Okay, so by finding that x equals 4 is one of our zeros, here's what we know. It's a third degree polynomial. This is going to have 3 zeros. We already have one of them. Well, let's use synthetic division so we can get this down to a quadratic and find the other 2. So I'll put 4 in the box. 1, 0, negative 11, and 20. Bring down the 1. And I apologize, I couldn't read my notes. It's a negative 4, not a positive 4. There we go. All right, so we end up with our quadratic. So from here, this is going to be x squared minus 4x plus 5. Now, if we could factor this, we would, but we know it's not going to work out because we don't have any other rational zeros. So we're going to go ahead and use quadratic formula here. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, keep in mind, it's really important when you have a negative b that you put it in parentheses like this before you square it. That was the thing a lot of you guys missed on the quiz. All right, so 4 plus or minus the square root of 16 minus 20 over 2. So square root of negative 4. The square root of negative 4 is 2i. And both the 4 and the 2 are divisible by 2. So I end up with 2 plus or minus I. And again, that's 2 zeros. I have a total now of 3. 2 plus I and 2 minus I. So degree 3, 3 zeros. All right, let's try another one. So again, we are going to use a graphing calculator to find the rational zeros here. Now, if you were to graph this, you're going to see 4 zeros, but 2 of them are going to be really, really ugly decimals. So the ones that are really, really ugly decimals, those are going to be the irrational zeros. We're going to have to get those from quadratic formula. So we can only go through this synthetic division process when we have the nice rational zeros. So for this example, if I were to graph this, the rational zeros here are going to be negative 3 and 1. So those are the nice pretty decimals or the pretty integers that I can find when I graph this. Now this time there's 2 of them. So we're going to have to go through the synthetic division process twice. It doesn't matter which one you start with, we're going to actually have to use both eventually. So let's start with negative 3. Let's write our coefficients. Let's bring down the first. I get 0 as a remainder like I should. So now I have to do this again with 1. But I'm not going to go all the way back to the beginning because right now what I'm left with is cubic. I need to get down to a quadratic. So I'm going to take what I just had, the answers from that previous one, and I'm going to go through this process again with the other 0 that I didn't use the first time. So let's bring down the first, do our synthetic division. Oops, and I can add, right? And again, I get a remainder of 0. Well, now, again, I've gone 1 degree less, so now this is squared. So I'm left with a quadratic. So now to find my last 2 zeros, I can use quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So 4 plus or minus the square root of 16 minus 4. Simplify the square root of 12. Both the 4 and the 2 are divisible by 2. And I get my other 2 zeros. So again, remember, 4th degree should have 4 total zeros. Negative 3, 1, 2 plus the square root of 3, and 2 minus the square root of 3. All right, so I know this is kind of a long process, but again, you can use a calculator to at least alleviate a little bit of it to be able to find some of those rational zeros to start. Again, I'll have a separate video that shows how to use the calculator to find those zeros, but other than that, that is it for today.